Well, good morning, everybody. Today I'm going to give you a brief overview of the landslide problem in southwestern Pennsylvania. This is a U.S. Geological Survey landslide susceptibility map of the 48 contiguous states. Areas of very high landslide potential are colored red. The biggest red area is the Appalachian Plateau region of the eastern U.S., southwestern Pennsylvania sitting at the northern part. There are other red areas around the country, typically associated with weak soil and rock units. Of course, California is a big landslide area. California gets a lot more national press coverage than we do because they have higher property values and movie stars' houses sliding into the Pacific. We don't get the press coverage even though we have more landslides because of our lower property values. Every year in southwestern Pennsylvania, landslides cause millions of dollars of damage. They displace people from their homes, and they occasionally injure and kill people. This house on the left was being torn apart by a landslide in 1974 in Brentwood Borough, south of Pittsburgh. This slide involved fill, which you can see here, over colluvium or old landslide debris. As Tony mentioned in his introduction, homeowners insurance doesn't cover landslide damage. Over here on the right, a rock fall, Sawmill Run Boulevard, Pittsburgh, February 1983. Killed 2 people, injured 1. Most injuries and fatalities from landslides are associated with cave-ins of soil excavations and soil trenches, as well as rock falls like this. Landslides of the sort you see on the left occur fairly slowly. You can walk away from them, if need be, run away from them. You can't run away from trench cave-ins and rock falls, however. Southwestern Pennsylvania has long been noted for landslides. This results directly from our geology, topography, climate, and history. Flat-lying, interbedded, strong and weak sedimentary rocks have been acted upon by processes of erosion, stress relief, weathering, creep, and sliding to produce masses of marginally stable colluvium, or old landslide debris, on our hillsides. These colluvial masses are often reactivated by heavy precipitation and by human activity, typically fill loading, toe excavation, surface and subsurface drainage changes. We also have an Appalachian heritage of throwing fill and dumping things on slopes. I'm going to now show you 2 large, famous, recent landslides to illustrate the impacts in our region. This section of Interstate Route 79 is located 15 kilometers or 9 miles west of downtown Pittsburgh. Oh, here's my cursor. The highway crosses the Ohio River on a bridge from Neville Island, extends up the west side of Killbuck Run Valley, crosses on a bridge to the east side of the valley, and continues further north. This highway alignment was chosen to avoid, to the extent possible, the village of Glenfield in the valley bottom and the road, houses, and stream in the valley bottom. When this section of highway was investigated and designed in the early 1960s, Pleistocene rockslide remnants and related colluvium were unrecognized. Construction began in 1968-69 with side hill cuts along here. These excavations removed toe support, reactivated old landslides. We had a 1 mile long active landslide laboratory from about station 900 to 955. These stations are in feet. I investigated these landslides in 1968-69 as part of my PhD research at Pitt, and I've been studying them ever since. I'm going to show you two cross sections. The first one at station 909, the second one at station 928. This overall cross section at station 909 illustrates the geotechnical framework of the slope and the landsliding. Lower part of the slope consists of various shales, in-place bedrock. There's a thin veneer of colluvium draped down it. My cursor has a hair trigger. The upper part of the slope has a thick, weak rock unit about 70 feet thick, comprised primarily of the Pittsburgh Redbeds claystone, which Dan mentioned earlier. Above that is 100 feet of a massive Morgantown sandstone. Deep-seated sliding occurred in the claystone, probably in Illinoisan time, a few 100,000 years ago. This is based on the generally accepted Pleistocene history of the region. The sliding could have been even earlier. This is a more detailed cross-section at station 928. The original highway cut as designed is shown by this dashed line. It had an inclination of 1 to 1 or 45 degrees across the shales. A bench at the top of the shale and a design slope of 1 1/4 to 1 or 39 degrees across the upper material, which was originally thought to be in-place claystone, but turned out to be claystone colluvium. When this colluvium was excavated, the old slide masses were reactivated, continuing upslope. In many areas, the slopes were stabilized by excavating to an inclination of 3 to 1 or 18 degrees. Some areas were excavated even flatter to 5 to 1 or 11 degrees. We took failure surface clay samples at station 928 and many other locations, tested them in the laboratory, but that's another story. This is looking north from station 900, April 1978. The cross-section I showed you earlier at station 909 would be up in here. The 928 cross-section way up here. You can see sandstone in a slide scarp back here, Morgantown sandstone. Colluvium excavated to inclination of 5 to 1 or 11 degrees. A wide catchment bench was excavated on top of the in-place shale to catch slide debris and keep it from going down on the road. This material has been creeping for the last 50 years or so, but it's just beginning to encroach on the bench. It's no threat to the road. Moving on, We learned a lot from the I-79 slides. We published a number of reports and technical papers from 1969 to 1981. Since that time, I've talked about these slides at numerous local, national, international technical conferences. All the things we learned from these slides, however, did not extrapolate a mile to the southeast. The I-79 slide area is up here. 1 mile to the southeast is the Killbuck landslide site. This is a major landslide that occurred in September of 2006 during site grading for a large shopping complex, which was to have been anchored by a super Walmart store. During the site grading, they placed up to 100 feet of fill on colluvium derived from the same Pittsburgh red beds that we saw over here at I-79. The people who investigated and designed the site work here either did not recognize or disregarded the colluvium. I took this picture out the window of a small airplane a week after the slide occurred. Slides down here, we'll get a closer look at it in the next picture. I wanted to show you I-79, the bridge across the Ohio River, I-79 extending up the Killbuck Valley to the slide area, which is back in here. This picture was taken by PennDOT on the morning the slide occurred, September 19th, 2006. The slide extended 1,000 feet long, 600 feet upslope, dumped 500,000 cubic yards of material across 4 lanes of Pennsylvania Route 65, 2 tracks of the Norfolk Southern Railroad. The slide did not quite reach the 3rd railroad track, nor did it get to the Ohio River. With heroic cleanup efforts like this, the railroad was reopened in 4 days. The road was partially reopened in 11 days and totally reopened a few months later. The road took longer because it was right up in the slide toe, a major slide toe area. This slide area was restored to pre-development conditions with vegetation and trees by 2014 at an estimated cost of $60 million. This is the way it looks now. Google Earth photo taken earlier this year. You've got benches and so on, grass, some little scrubby trees. This Killbuck slide should never have occurred. What caused it? The first words that come to mind are ignorance, incompetence, stupidity, and greed. These human factors in landslides are yet another potential research area. As George Santa Anna said, those who cannot remember the past are condemned to repeat it. Well, that's my brief overview of landsliding in southwestern Pennsylvania. Thank you for your attention. Are there any questions?